Okay, probably going to have to break this down into two things. So basically, here's what we have. We've got this particle A is coming up here, boom, and it's going to go flying off this way, and this one's going to go flying off this way. I've already talked about elastic and inelastic collisions. This is an elastic collision for the most part. And here's the thing. Mass 1 is coming in with an initial, the total momentum of the system is going to be equal at the end. And we're going to just have to break this down into its components. It's not that hard. It's an accounting problem. You take care of each of, so I've got on the initial one, this is equal to 0, and this is in the x direction. I also have, what do you think about these two y components right here? Do I have a y component? What's the y component going this way? 0. So the y component is going this way, 0. So this one's going in the positive x direction or y direction. This one's going in the negative y direction. They should cancel each other out. All right. So let's take a look at how we'd solve this problem. These are fun. I really like them. So I'm going to set it up for you. And that's all I'm going to do. So I got mass 1 coming in here at 4.5 meters per second or whatever they said. I can't remember. I don't really care. That's mass 1 or mass A. And then I've got mass B just sitting here. It's not doing anything. So the momentum before in the x direction is equal to the momentum after in the x direction. And the momentum before in the y direction is equal to the momentum of the system before in the after in the y direction. Okay? All right. So that's what we're going to do. Okay? And then the after part, let's look at the after. Here's the before total. And now let's look at the after part. The after this is 65 degrees, this is 37 degrees. Here's B, here's A. And we don't know what VA final is. We don't know. And we don't know what VB final is. We have no idea. But we can get it. We can get it. And I'll show you how we set this up. So, but look at the final. The final has, you've got a final in the X, and you have a final in the Y. Okay, so the final velocities in the x direction are ma, v final, times the cosine of 65, v final a times the cosine of 65, and plus mb, this is p final x, is equal to mass of b times the final velocity of b times the cosine of 37. So what do you think final in the y is ma v final a times the sine of 65 plus mb. Actually, we got to be careful here. It's minus because it is going this direction. Minus mb velocity of b sine. Final velocity of b sine of 37 degrees. All right, so you look at what happened before, so what happened after. So here we go. So you've got ma, so you got the momentum before in the x direction is equal to ma times va naught plus 0 is equal to the momentum after in the x direction, which is equal to ma times v1 our VA final, which I don't know, plus MB in the x direction, VB final in the x direction, which is equal to MA times, which we found, VA times the cosine of 65 plus MB times the sine or cosine of 37, I believe. Okay? Now, look at this. I got two unknowns and only one equation. I got two unknowns. I forgot to put my VB in there. Two unknowns, only one equation. Let's look at the x coordinate.